This tutorial is part of the GTF-CC online course on the identification of priority areas for multisectoral interventions for cholera control. Once data has been imported into the PAMI Excel tool, indicators, scores, and priority index are automatically calculated in the tool for each geographic unit. In addition, summary figures are computed to help decision-making on PAMIs at the stakeholder validation. This video will show you where to find and how to use and interpret the different outputs of the PAMI Excel tool. Data has been imported in the data input sheet, and calculations have been performed in the priority index calculation sheet. In this video, we will go through the sheets R2 to R5, which are the sheets where outputs are displayed. Let's start with the sheet AR2 overview tables. The first section on the upper left side provides an overview of the data set that was analyzed, including the total number of geographic units in the country, the duration of the analysis period, the number of geographic units where cholera cases were reported over the analysis period, the total number of cholera cases and deaths reported over the analysis period, and associated case fatality ratio, the total number of cases tested and tested positive for cholera over the analysis period, and the test positivity rate. Go through these summary figures to check that they are consistent with your data set. If you detect any inconsistency, this may indicate errors in the formatting of your data set. Check that your data was formatted in accordance with the data model template prior to upload into the PAMI Excel tool. Make corrections as needed and re-upload your data. Inconsistencies may also indicate errors at the data import steps. Check that all geographic units were included in the calculations. Make any corrections as needed and refresh the calculations. The second section on the upper right side shows how epidemiological indicators have been scored according to the distribution parameters of each epidemiological indicator in your dataset. The scoring scale of each epidemiological indicator depends on the median and 80th percentile value that are specific to your dataset. The last section shows how testing indicators have been handled in the analysis. Whether or not a testing indicator can be included in the analysis and, if so, which testing indicator depends on the representativeness of cholera testing in your dataset. This section shows the level of representativeness of cholera testing in your dataset, and as a result, how testing was managed in the analysis. If the representativeness of cholera testing was assessed as acceptable, the positivity rate was included in the analysis. This is how this is displayed in the tool. The positivity rate is scored on a 3-point scale. In this situation, the maximum value of the priority index is 12. If the representativeness of cholera testing was assessed as suboptimal, the number of years with cases tested positive was used in the analysis. This is how this is displayed in the tool. The number of years with cases tested positive is scored on a 2-point scale. In this situation, the maximum value of the priority index is 11. If the representativeness of cholera testing was assessed as insufficient, no testing indicator was included in the analysis. This is how this is displayed in the tool. In this situation, the maximum value of the priority index is 9. Overall, going through the figures provided in sheet R2 is essential for you to be able to understand how the analysis was performed and how the priority index was calculated depending on the parameters of your dataset. Now let's look at the sheet R3, Priority Index Summary, which is an essential sheet for discussion at the stakeholder validation to determine the priority index threshold. This table provides information on geographic units by priority index value. The priority index values are displayed in the first column. For each priority index value, the table shows relative and cumulative numbers and percentages. Relative numbers and percentages are for the geographic units that have a priority index value equal to the selected table line. For example, looking at geographic units that have a priority index equal to 8. 6 geographic units have a priority index equal to 8. About 1 million people live in geographic units that have a priority index equal to 8. This represents about 5% of the country population. Nearly 2,000 cholera cases were reported in geographic units that have a priority index equal to 8, which accounts for about 4% of the cholera cases reported over the analysis period. 81 cholera deaths were reported in geographic units that have a priority index equal to 8, which accounts for about 12% of the cholera deaths reported over the analysis period. On the other hand, cumulative numbers and percentages are for all the geographic units that have a priority index value equal to or above the selected table line. In other words, all geographic units that would be PAMIs if the priority index threshold was the selected table line. Looking at cumulative values, if the priority index threshold was set to 8, in total 36 geographic units would be PAMIs. 38% of the country population would live in PAMIs. 93% of the cholera cases reported over the analysis period would have occurred in PAMIs. 81% of the cholera deaths reported over the analysis period would have occurred in PAMIs. Cumulative figures on the population living in PAMIs and on the number of geographic units that would be PAMIs, depending on the selected priority index threshold, are proxies for the feasibility of the future NCP. Cumulative figures on the cholera cases and deaths that occurred in PAMIs are proxies for the potential impact of the future NCP. Therefore, figures provided in sheet R3 are essential to determine the priority index value, which in the country-specific context represents the best balance between the feasibility and the potential impact of the future NCP. For example, if the priority index threshold was set to 12, one geographic unit representing about 2% of the population would be PAMI. Implementing multisectoral interventions in PAMIs would most likely be feasible. However, considering that 15% of the cases and 6% of the deaths occurred in PAMIs, implementing multisectoral interventions in PAMIs would be likely to have a moderate impact to control cholera. As a result, selecting 12 as a priority index threshold would not achieve a good balance between feasibility and impact. As another example, if the priority index threshold was set to 4, 99% of the cholera cases and deaths would have occurred in PAMIs. Implementing multisectoral interventions in PAMIs would have a major impact to control cholera. However, considering that 67 geographic units representing 68% of the population would be PAMIs, the feasibility of implementing multisectoral interventions in all PAMIs would most likely be highly challenging. As a result, selecting 4 as a priority index threshold would not achieve a good balance between feasibility and impact. Overall, going through the figures provided in Sheet R3 will help stakeholders decide on the most appropriate priority index threshold, taking into account both the feasibility and the potential impact of the future NCP. Once a priority index threshold has been set by country stakeholders, the list of initial PAMIs based on the priority index in a country is established. All geographic units with a priority index equal to or above the selected threshold are PAMIs. However, in particular circumstances, if it is determined that the priority index may lack reliability in specific geographic units, stakeholders may also wish to look into the vulnerability to cholera of geographic units that have a priority index below the priority index threshold. Sheet R4 is used for that purpose in order to assess the presence of vulnerability factors in geographic units that have a priority index below the selected priority index threshold. However, remember, selecting additional PAMIs based on vulnerability is optional, and in any case, the number of additional PAMIs must remain very limited. Let's have a look at Sheet R4. Each table corresponds to a cholera vulnerability factor and shows the number of geographic units where the vulnerability factor considered is present and the number of geographic units where it is absent, depending on the priority index value of the geographic units. For example, let's look at the vulnerability factor, sharing borders with a geographic unit in a neighboring country that is affected by cholera outbreaks, or that is a PAMI. Let's imagine stakeholders agreed on a priority index threshold equal to 10, and now they wish to explore vulnerability factors in geographic units that have a priority index below 10. We can see in this table that 4 geographic units have a priority index equal to 9 and have this vulnerability factor present. To know which are these geographic units and which other vulnerability factors may be present in these units in order to better assess their vulnerability, right-click on the cell that shows the number of geographic units with the vulnerability factor present. Select Show Details. By clicking Show Details, a new Excel sheet is generated showing all information about the geographic units considered. This sheet shows how many vulnerability factors are present in total in each of these geographic units and which ones. This can help guide discussions on vulnerability to cholera at the stakeholder validation in order to identify a limited number of additional PAMIs. Overall, R4 is an exploratory sheet to help assess the cholera vulnerability of geographic units that have a priority index below the selected threshold value in order to identify a few additional PAMIs based on vulnerability factors, if justified in the country-specific context. We will now look into the last sheet of the PAMI Excel tool. This is sheet R5, Table PAMI Export. This table summarizes all key information and allows you to manipulate, sort, and filter the data and the outputs depending on your needs. For example, you may filter the geographic units with a priority index equal to 9 and 8 vulnerability factors present or more. You can also export this sheet to prepare maps of PAMIs in GIS software or make any further analysis in a statistical software. Overall, Sheet R5 is for you to manipulate and explore the outputs as you need. As we wrap up, we encourage you to explore the PAMI Excel tool and practice using it, including with the training datasets available online. If you have additional questions, you can consult the user guide of the PAMI Excel tool. You're also welcome to contact the GTFCC Secretariat. We're always here to support you.